How do we know this unique looking rock is a meteorite from space? It hasn't been sent to a lab for analysis, but there are some features that give it away. Let's take a closer look. The first thing I want to note here is the shape of this stone, and it is what we would call flight oriented. That is to say, it has sort of an aerodynamic shape. You can kind of visualize how it would have flown through the atmosphere in kind of a stable orientation. Not all meteorites have this. Matter of fact, most of them will tumble as they come into our atmosphere. But ones that are not, we consider those to be oriented, and the shape is one characteristic of those oriented meteorites. One of the other things that's pretty visually striking about this meteorite is the remnant fusion crust that's on it. So when these rocks come through our atmosphere, they essentially burn up. The outer layer burns up and that turns it black, this charred exterior that's somewhat frothy looking. Now, this meteorite was found long after it landed on Earth, so that's why a lot of that fusion crust is no longer there. It wears away over time, but we do have remnants of that black sheen on different parts of the meteorite, which indicates that it did come through our atmosphere. Speaking of fusion crust, this reveals something else interesting about the oriented nature of this meteorite. Sometimes when the meteorite is oriented, the outer layer of the fusion crust will melt a little bit, and that'll leave lines as it encounters air resistance. And it's a little hard to see here, but if you look closely, you can see some of those lines. And once again, those indicate the direction in which this meteorite flew down and landed on Earth. Finally, within the fusion crust, we also see contraction cracks. These are little, small, thin cracks that run through the fusion crust that are the result of the meteorite cooling down rapidly after it heated up coming into our atmosphere. They don't always survive on the ground, and they certainly do get weathered away, but we do have evidence of those remaining in this meteorite. There are a few other ways we can tell this is likely a meteorite. One of those is the weight. This thing is quite a bit heavier than you would expect it to be for its size. That's due to the presence of metals in it that makes it heavier. And it also makes it a little bit magnetic. So sticking a magnet, it will stick to this rock. Something else we could do, we could actually cut open this meteorite, make a slice of it. We would likely see some evidence of chondrules, since it is probably an ordinary chondrite, something we've talked about on this channel. Those little spheres of minerals that were once liquid and then hardened at some point. So we have all of these things that tell us this is almost certainly a meteorite. I do want to keep it straight with you here, though. I can say with almost certainty that this is a meteorite based upon all the samples and all the evidence I have available, but the only way to know with 1,000% certainty is to send a rock to a lab where they'll do things like XRF and oxygen isotope analysis. That's the only way to know for absolute sure. If you like learning about space through the lens of meteorites, make sure to like and subscribe. I've got a lot more from my collection that I'm excited to share with you.